Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to talk about how to do structural model assessment in SmartPLS-4. We know that the path model consists of two parts. One, the measurement model, and the second one is the structural model. In my previous video, we have already discussed that how to do the reliability and validity testing of the outer model, also known as the measurement model. Depending upon that our construct is formative or reflective, we have adopted different procedure for its testing that we will see later on. Now let me try to make you understand what is the difference between measurement model and a structural. The measurement model is that when we are trying to establish a reliability and validity of the measured variable with the construct, that is the football team players. These are the team players and this is a football team. So when I am trying to establish a reliability and validity, I am talking about measurement. Once it has been established, and when I try to study the relationship between construct to construct, blue to blue, then it is a structural model. There is a flowchart which we have to follow. This is given by the authors. Does the model include reflective construct? Yes. Then we had seen in my previous videos that the evaluation criteria of the reflective model is to check the indicator reliability, internal consistency reliability, conversion validity, and discriminant validity. If it does not consist of reflective and it is a formative one, we go for conversion validity, collinearity, significance, and relevance of weight indicators. Now, once both of them, depending upon reflective or formative, have been established, then we go for the structural model assessment, in which the first one is testing the collinearity, then the predictive relevance, then the significance and relevance of path coefficient. In my previous video, we have also discussed that how to establish the reliability and validity testing for the reflective construct, in which the indicator reliability was considered, internal consistency reliability was considered, conversion validity was considered, and divergent validity was considered. The conversion validity of the formative construct was established with the help of single global item suggested by Chin. Now let's see how to do the structural model assessment. Basically, it is a relationship between the latent variables in the structural model. And this relationship is also called path coefficient, which is indicated by a small p. The rule for thumb for evaluating the PLS-SAM result is, if the measurement characteristics of constructs are acceptable, that is, if the reliability and validity is established, then only we can go for running the structural model. The second thing is path estimates should be statistically significant and meaningful. Now here, the thing which we want to run is R square. That is a coefficient of determination. That is the explained variance. Here, we will try to study that how much the exogenous variables are able to explain the variance in the endogenous construct, or rather exogenous constructs are able to explain how much variance in the endogenous constructs. And for this, we are using the measure is R square, the coefficient of determination. It values, the range of its value is from 0 to +1. The idealistic situation is that it should be having the value nearer to 1. Three methods are there in PLS-SAM: centroid weighing scheme, the factor weighing scheme, and the path weighing scheme. Most of the time we work on the path weighing scheme because the objective function here is to maximize the R, so that more and more variance can be explained of the endogenous construct. PLS-SAM algorithm works on standardized latent variable scores. So when you run this software, the package standardizes both the raw data of the indicator as well as the latent variable scores, and then only it will run the algorithm. The algorithm calculates the standard coefficient between minus and +1 for every relationship in the structural model. This means that if any two construct is getting a relationship nearer to +1, it indicates a positive relationship. If it is nearer to -1, it indicates a negative relationship between the constructs. And if it is nearer to 0, it means that the relationship is very weak. For structural model assessment, we go for significance of the path. The statistics which will be generated are the t value. So if any path is having the value more than plus or minus 1.96, we will say that the path coefficient is significant. And if the p value is less than 0.05, then also we can say it is significant. We will have to check the presence of 0 in the bias corrected confidence interval. If the 0 is present in between this interval, then that construct is not significant. The second thing which we check here is R square. R square is also known as an in-sample explanatory power, and its value ranges from 0 to 0.25, it's a weak, 0.25 to 0.50, moderate, 0.50 to 0.75 is a substantial. The next statistics which you consider is a predictive power, that is a Q square. It's an outsample predictive relevance, and its range is from 0, if it is near to 0, it is very small, 0.25 medium, and 0.50 large. Now, what's the difference between explanatory power and the predictive power? Explanatory power is known as the in-sample statistics, and predictive power, Q square, is outsample. A layman difference can be that there is a professor who has trained his students on 80 MCQ. If the same set of 80 MCQs are asked in the exam, it means that I am testing the R square. The data file on which the algorithm is created, we are trying to check its R square. It is in-sample explanatory power. When the same professor gives a new 20 MCQs to his student, that is, a new data set is given to the algorithm, and the statistics which is computed to predict that will our model work on the new data set or not, that is a Q square statistic. And that's the reason we are saying it is a outsample predictive relevance. Now, there are some steps which have been suggested by the authors. The first step is assess the structural model for the collinearity issues. Second step is assess the significance and relevance of the structural model relationship. The third step is assess the level of R square. Fourth step is assess the effect size F square. The fifth step is assess the predictive relevance Q square and the Q square effect size. In first step, we will check the collinearity issues. We should not have the value, the tolerance value of 0.2 or lower, or VIF of 5 and higher as suggested by the author. Now, let us run the first step in SmartPLS. We have already discussed about this model in my previous video. I'll request all my viewers to kindly refer my previous videos to understand the flow of this series. Now, to get the VIF value, I'll go in calculate PLS-SAM algorithm. Make sure it is a path. Start the calculation. The new features of PLS-SAM are when you hover your mouse on any construct, it will give its R square adjusted, rho, AVE, Cronbach alpha, composite reliability. Similarly here also. You click on open report. So this is a first step which we are considering. I'll go in collinearity statistics, and you can see here all the values are less than 5. You can check for outer model also, and you can check for inner model also. They are less than 5. And therefore, our first step is clear. In case of dispute, if there was a collinearity, there may be a problem of cross loadings, which we have discussed in my previous video, that how to resolve the problem of cross loadings. Now we go on the second step. The second step is to see the path coefficient. We'll have to run the bootstrapping to get the path coefficient. So a path between construct to construct will be significant if the p value is less than 0.0. Now, how we will test this? Let's see in SmartPLS. calculate, bootstrapping. Make sure that you keep this bias corrected and accelerated bootstrap on. The authors have recommended that you should keep this subsampling on. The figure should be 5,000. Start the calculation. You can see here the path coefficients value, or rather it is only showing me the p values, not they are not path coefficients, they are showing me the p value. To get the path coefficient, you activate from here the path coefficients and p value, you will get. Normally, it is a custom that for outer model, we report t values, and for inner model, we report path coefficients and p value. Here, you can get r square. Whatever you want to report for endogenous, you can report from here. You can choose from here. You want to report AVE, composite reliability. Normally, we keep r square. Now, there is one more thing which you can do here is, while reporting your results in the paper, you activate the highlight path and you can use absolute values. So the thickness of the arrow will represent the magnitude of the construct affecting the dependent variable. It means that the more the thickness, more is the effect. If you change this to relative value, you will get like this. More thickness you will get. Now, this is a relative thickness which you will get. You should report this result from here. This diagram, you should report it. And you will also get the Excel sheet. To get the Excel sheet, click Open Report. And now click on Path Coefficient. You'll have to see the p-values of all this. So co-workers to staying intention, the p-value is less than 0.05. It means that the effect is there. The behavior of co-worker is affecting the staying intention of an employee. Fine. Environmental perception to staying intention. Its p-value is less than 0.05. It means that there is a effect is there. Job satisfaction to staying intention, p-value less than 0.05. It means that the effect is there. In fact, if things are indicated in green, it means that the effect is there. Now, how much the effect is there? So you can see here 0.336, 0.074. So with every increase in environmental perception by 1 unit, the staying intention is affected by 0.336. The next thing which we should report is confidence intervals bias corrected. The zero should not be present in between this range. If zero is present, it means that this exogenous construct is not going to affect this endogenous. You can see here, it is going from these values, that is from 2.5% to 97.5% confidence interval. This is positive, this is positive. It means that the zero is not present. For zero to get to be present here, one value will be negative and another will be positive. If that is a scenario, that construct, or rather that exogenous construct, is not going to affect the endogenous construct. So here it is plus, 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 all are significant. So this was a step 2. Now we will move to step 3. That is a coefficient of determination. It is a most commonly used measure to evaluate the structural model. Basically, it represents the combined effect of all the exogenous construct on the endogenous construct and how much they are able to explain, the amount of variance which is explained on endogenous construct. So, how we will run this? Again, we will go in SmartPLS, calculate, PLS7 algorithm, start the calculation. You can get the value from here also. You can see r square is here also, 0.347. Hover your mouse on the construct. But for reporting purpose, you can go and open the report and you will get r square here. Now there are some threshold limits which have been given. First of all, see the value. The values which have been given by the author are, if it is 0.25, then it's a weak. that is a weak explanatory power. 0.5 moderate, 0.5 is a substantial. Let us see our values. So 0.347, it's a moderate explanatory power. Step 4 is to determine the effect size. So what is the definition? The change in R square value when the specified exogenous construct is omitted from the model and can be used to evaluate whether the omitted construct has a substantial impact on endogenous construct or not. By doing this, we measure the effect size. How? Let's see. We are having this model. The R square is present. So if I want to measure the effect size of job satisfaction, what I'll do, I will delete it. And then I will measure the R square. So it is 0.34. That is, when I am measuring the effect size of job satisfaction, I'm deleting the construct and I'm calculating its R square. So this is R square excluded of job satisfaction. And this is R square included of job satisfaction. Now we will apply the formula here. So the R square included minus R square excluded and 1 minus R square included. So whatever we get now. So the guideline is that if you get F square equal to 0.02, near to 0.02, the effect is small effect. If it is 0.15, it's a medium effect. And if it is near to 0.35, the effects are large. This is according to Cohen, 1988. Now, how we can get this value in SmartPLS? Let's see. I'll open the report and I'll get the value from here, F square. See, 0.0323, 0.136, 0.092, and all those which are in red, their effects are very low. You can also get the charts from. So most of them are having, you can say, a medium effects. Very large effect is of only environmental perception on staying intention. So its effect size is much larger. You can also customize this chart and you can change the threshold limit from here. See, if I change the threshold limit, you can see what happens. So at present, we have kept the threshold limit 0.15. You can also do that. Now, the model fit in SmartPLS is in a very nascent stage. You can report that also. So ideally this value, that is SRMR, standardized root mean residual, this value should be less than 0.08. It means that the residual error is 5.2%, which is quite good. And the next thing which you have to report, you can report is normative fit index. It should be nearer to 0.9. The fifth step is blindfolding and predictive relevance of the model. This has been developed by Stone and Gizer, Q square value 1974. The ideal value of Q square statistics is greater than 0. Q square statistics will be only generated for endogenous construct. It will be we will get only for endogenous. We will not get the value for exogenous, and we will not get even the value for formative endogenous. The value will be only available for reflective endogenous construct. The Q square of blindfolding procedure represents a measure how well the path model can predict originally the observed value. This I'll explain by giving you an example in the next slides. The formula for this is Q square is equal to Q square included minus Q square excluded upon 1 minus Q square included. In this blindfolding, the data at some interval is deleted. We have to specify that you delete the particular data at the interval of 7, 6, 5, 4, 3, 2, 1. After that, when the data is deleted, let me show you. what actually it does. See, this is the data. When I specify the deletion that d is equal to 7, then the data at 7, 6, 5, 4, 3, 2, 1 will be deleted. It will be replaced by me. Then what it will do is the algorithm will compute the difference between the actual value, what was there here, and the value which is predicted by the algorithm. Naturally, if the difference is less, it means that the algorithm is able to fit the data appropriately. There are some conditions which we will have to remember. For blindfolding, for q square value, it only works for endogenous variable. In layman terms, dependent variable. And the dependent variable should be reflective. Now in SmartPLS-4, blindfolding, a separate menu is not available, which was there in previous version. Now we have to run this from PLS predict menu only. PLS predict menu only. So how we will do that? Let's see. Calculate PLS predict and start the calculation. Open the report. MV prediction summary. You can see the q square predict value is now available. So as we have discussed, it only calculates for endogenous construct. So this is endogenous. All the arrows are coming in, and it will only calculate for reflective construct, right? Now, what are the thresholds which have been specified by the authors? If for any construct, the q square value is between 2% to 15%, then we are having a weak predictive relevance. If it is between 15% to 35%, we are having moderate predictive relevance. If it is more than 35, we are having strong predictive relevance. Now let us check for our model. Q square 0.2232. Okay, SI. You will get q square predict in manifested variable as well as the latent variable. In manifested variable, it will give for each and every measured variable of endogenous construct. But we should go in LV prediction summary, PLSM, and we should see overall the q square predict, and its value is 0.326. Let us try to match the value. It is almost nearer to this range, and therefore our model is having a moderate predictive relevance. So these are 5 steps in which you can do the structural model assessment. Let us have a quick recap of the steps one by one. See, this is a model is there. First thing which I should do is I should check for multicollinearity. You can see from here. Now the next thing which I should do is calculate bootstrapping. Start the calculation. So I can report the results from here, or I can go and open the report and I can report this path coefficient as well as the confidence intervals bias corrected. You can report the model fit here also directly. So to report the model fit, I'll go here and calculate PLSM algorithm, start the calculations, open the report, and you can report the model fit from here. Right? So this is the second step, which is there. The third step is to report R square. The fourth step is to report the F square. And the last step, which is there, is a Q square statistics. For that, you will go and calculate PLS predict, start the calculation, open report, and click on LV prediction summary, latent variable prediction summary. You can click here. and you can report this. This is a way you can report the structural model assessment in SmartPLS. For more videos on SmartPLS, kindly subscribe to my channel. You can see my playlist in which I have already uploaded many videos which are related to structural equation modeling SmartPLS. Please don't forget to press the like button. Please subscribe my channel and you can follow me on LinkedIn and Twitter.